Sometime last year I got this C64. While it didn't seem to work at first, running some programs revealed some graphics glitches and text distortion. No doubt it's time for a deep dive into C64 repairs for me. Have you ever fixed
an old computer? I did, many times. I'm the vintage collector and these are my stories.
Even though I got two 1541 drives along with this C64 and the monitor, I won't be going into those today. But I can take it up front and tell you those aren't working either. But for now, let's focus on the C64, and this one turned out to become a repair odyssey for me. I had my first ever look at it already in June 2023, so almost 1 year ago. All I wanted was to play around with CPM for the C64, but already in the early stages I noticed some screen distortions and random lockups. Especially when it comes to bold text, it was barely readable. Now compare this to this picture I took from my C64C. One might think this was wrongly captured on camera, but no, it really looked as terrible as you see here on this alternative picture taken with yet another camera. Only non-bold text, like the 09 here at the bottom, was somewhat readable.
You certainly used the antenna connector, didn't you?
Nah, I used the composite video cable, but more on that later. Here's another program where the image distortion is also visible, with the left-hand panel readable and the right-hand side in bold letters is almost blurred beyond recognition. At this stage, I didn't have yet the diagnostic harness, nor even a remote idea on C64 repairs. So I just went with some diagnostic tools I could find. Already the Test64 utility tells me something's wrong with this machine, as it exposed different kinds of malfunctions at some stages. Although it also seemed to work sometimes, and this looked actually okay thus far, it would also report a failure on the kernel ROM. And even though it said the character ROM was okay, I sporadically also saw any of these, which led me to believe I should also care for the character ROM. The German test build generator did seem to work, and it all looked fairly okayish, but when watching closely you may catch there's some level of color bleeding. I also ran Dr. 64, which also revealed some color bleeding and distortion, though was not to the same level on all possible color combinations.
This is all well and good, but who says it's not the monitor?
Very well. Here's some pictures with that very same C64 hooked up to another CRT I have. Compare this to the pictures I took on the same monitor using my C64C. It as well has some very slight bleeding, but looks a lot better than the other. It's clearly indicative the issue is with the C64 and not the monitor. This is where I then left off and went to do some further investigation. I had a parallel C64 project running at the time with my other C64, the aforementioned C64C, which seemed to have a keyboard problem. So in order to get any further, I organized myself a diagnostic harness and revisited this machine a few weeks later. And it already brought some stuff up, like VIC-II being bad. This is the MOS 6526 complex interface adapter, CIA for short, which acts as an I/O controller. Also, U18, which is the MOS 6581, otherwise known as SID, the sound interface device, seems to be bad. In addition to that, it complains about keyboard control and user port faults. That's somewhat odd, as I had expected to tell me rather a fault in U19, which is the MOS VIC-II, the video interface controller. On the other hand, I have seen it often enough that one symptom sometimes is caused by something different and leads you in the wrong direction. And if the diagnostics tells me anyway these things are bad already, then why not start here with the repair?
I would still go with the VIC-II replacement first.
You've been looking at the pictorial guide, weren't you? I agree, but still, let's do one step after another. When I removed the mainboard from the chassis, I gave it a closer look and found out that this is actually a 326298 revision A mainboard, so one of the very first generation. So I organized the SID replacement. After some reading, I understood that not all SID replacements support paddles. And although I don't have or use paddles, it's clear I would only go with a SID that has working paddle support, so I went with backSID. At the same time, I would then also swap the U2 CIA and rerun the diagnostics. And in fact, swapping the CIA helped to make the serial port error go away, and also U2 reports fine now. Still, this sound seems to work and the error for the keyboard and control ports still remain. And apparently I can't hear any difference between the backSID replacement and the original SID. I was then reading up on the details of said mainboard revision and went also into some more details about the diagnostic harness, with this source actually stating that the bad is not fully indicative but more likely a possible cause of failure. To me that sounds quite a bit similar to the original IBM PC BIOS post, which was ever mentioned to be a confidence test and not a real in-depth diagnostics. And in fact, this goes all along with the C64 service manual, which confirms on page 1-6 that the control port may report bad, including the SID on U18 on early board revisions because of wrong value capacitors. So this actually seems to be a false positive from the diagnostics. I would swap out those caps eventually once I get hold of the proper ones. Luckily, there's some schematics available for the 326298 boards, which will come in handy at some point. In the meantime, I was recording all capacitors in order to swap them out. A tedious task. But let's not forget about our sponsor today, PCBWay. I had the opportunity to partner with PCBWay and go into deep with their 3D printing services. Although a simple knob, it helped me to restore the appearance of this compact portable. Likewise here on another compact machine with a spare trim panel. What about the SGI-02 with a beautiful reproduction of the power supply cover and the drive sled? And although it belongs to my sister channel and that video hasn't actually been published yet, but look at these 3D printed parts I used for building a scale model of Kit's Semi. So if you need services, maybe PCBWay can help you. And now, up to the soldering part. Once I had everything prepared, I swapped out all capacitors. Now there's people saying as long as there's no indication of failure, you shouldn't. That lies in the eyes of the beholder. I tend to swap the caps if I'm anyway tinkering around with the machine, just to be sure. I saw it often enough that only weeks after working on a machine, it failed and then I had to do it anyway. So here we go. You may notice by the way that there is some modifications on the underside. I guess these were made by one of the previous owners and I'll have to look at this again shortly. But first I'll have some more diagnostics, like here is the C64 test to run some register tests. As you can still see here from the bad picture quality, it didn't improve a bit yet. At the same time, it also didn't get worse.
I'm telling you, it's the VIC-II.
As mentioned before about the bad ROMs, I got myself some new ROM replacements, basically all three of them, the kernel, basic and the character ROM. Unfortunately, two of the ROMs were not socketed, so I had to unsolder them. In order to facilitate future maintenance, I was then anyway putting some new IC sockets in there to make them easier to swap. After this procedure, there was one noticeable difference. I wouldn't exactly call it improvement, but when you look at File Browser 64, I still have the distortion on the bold lettering, but there's also a somewhat clear to read text underneath now, something that I didn't see before.
I still believe you should look into the VIC-II.
Sure, but don't forget, so far I have swapped a faulty ROM, a faulty CIA, identified the SID from not being faulty, and the error about the bad control port being a false positive. All in all, that's quite some progress already. A friend then also referred me to Sven Peterson, whom I ended up having an extensive chat with about how to approach the repair. So I was then eventually looking at the video circuitry.
Finally, you're getting to the point.
This machine sucks. I don't mean the Commodore 64 in general, I just mean this machine.
It helped as well that the Retro channel had published a video about improving the video quality on the NTSC version of the 326298 mainboard. I can only recommend you go over and watch it, as Mark is going quite into detail, and this helped me pushing me forward on my own repair.
They have a pretty rubbish video output. There's only composite video, and it's pretty terrible at that. There is no Chroma Luma output. Technically there is just Luma, but there's no Chroma from these machines, so it doesn't comply with either the Commodore video, which used separate Chroma and Luma, or even S-video. So you're pretty much limited to RF or crappy composite. Well, crappy RF and crappy composite, I should say.
Although I have the PAL version myself, I was looking deeper into the schematics. And I scratched my head in dismay when I actually found this trim pot here on R10 and R11. Obscure enough, the schematics are not referring to a trim pot, but just to plain resistors. And also Mark of the Retro channel is only ever talking about resistors.
So if we go by the schematics and put a 120 ohm resistor in there, that should bring our voltage level back into spec. I don't know why there's a 300 in here, it doesn't seem to make any sense, it's just Commodore being Commodore, I guess.
With the current setting applied, the trim pot reports roughly 126 ohms of resistance. So I was adjusting the trim pot a bit, and as you can see here, depending on the resistance value, the video distortion is better or worse. This is better visible here, where we have that oversaturation and bleeding, which just gets a tiny little bit better once I'm decreasing the resistance value.
I totally don't get why you're wasting your time with this. It's the VIC-II.
First and foremost, because I don't know if that trim pot belongs there or not. As I already discovered some modifications on the backside, it's very likely that this was also added at some point in history. Hence I'm about to remove the trim pot and replace it with regular type resistors to be more in line with the original schematics. Still, I'd consider Mark's suggestions on the resistance value to improve the video output. And while this improved it a bit already, I still observed this bleeding out on the horizontal bars. Anyway, I'm uncertain if those other modifications have something to do with it or not. So to exclude this, I attempted to identify what these modifications are doing. Typically, capacitors are used to hold a charge, smoothen outputs or to filter interference, to just give some examples. It's very likely that these had been applied in retrospect, as the solder joints look handmade. Let's take this resistor here, which is bridging a trace that had been deliberately cut for unknown reasons. On closer inspection of the schematics, I see that there is 3 resistors in series, so I measured them all and got different resistance values for either R5 or R37. Interestingly enough, those match the resistance values for later board revisions. Now, even if the schematic says there's a resistor between R5 and R37, this mainboard revision doesn't give it a name, whereas only later revision 251183 refers to it as R100. So, to me it's unclear if this was an attempt to fix something on this board using a later year schematic, or if that resistor and the new values, which match with later iterations, were indeed factory installed already. Anyway, this is one modification I definitely keep in, along with this capacitor here. Why? Because as I drew it how it sits beside CR1, it seems to match the other unnamed capacitor up here. As I couldn't find any other capacitor that sits between the R5, R100 and CR1, this one seems to be correct at least from a schematic perspective. But what about this capacitor here, which doesn't seem to make any sense? It's a 0.1 UF capacitor on the RF box between positive in and ground. One might think this is an interference filter. Now it seems somewhat superfluous, as you have already one on C16. And check this on the oscilloscope. To me, this looks the same. I guess I'm about to remove it, as there's no mention on the need for any such capacitor anywhere, not even for later board revisions. Now here's another one, which is hooked up between ground and pin 30, which is address line 6 of the VIC-II chip. I have no idea what this one is doing either. So off it goes. And this capacitor here is also interesting. After I drew it in, how it's also wired up between the ground leg of C29 and pin 1 of U25, I realized that there is a mention of any such capacitor on the schematic. Now, I do have a different capacitance value, which doesn't really match up with the annotations on page 1. Also, there's no C107 location on this board, or I simply didn't find it. According to my reading, it should be somewhere close to the video circuitry. However, we already noted that there's also no R100 position, so maybe as well this was added as an aftermath. Although it's pure speculation, the fact that this resistor here is of a different make than the others may be indicative that this one was actually factory installed. At least it seems to make sense, as the resistor is not only mentioned in the schematic, but as it sits on the CAS line, so we're talking memory latency here, it seems to be there for a potential timing delay reason. But I would really need to drill down to affirm this statement. All in all, that makes 3 modifications on this board where I could confirm that they at least are in line with the current or a later year schematic. As for the other 2 modifications, I removed them as I don't know what they're good for. I will now as well attempt a modification myself to follow Mark's explanations on how to add Chroma output. As he explains it himself in his video, the key is to redirect the audio line from the SID chip. This is achieved by removing the capacitor C12 and reroute the negative side pin. When you look at the top of the mainboard, this is the pin on the left hand side, or if you flip it to the back side, it's the one on the right hand side. Either way, pay attention you choose the correct pin. Then route it to the right hand side pin of the C79 capacitor. Again, check out Mark's video, as he's explaining this in greater detail. However, with that fix applied, it's already imminent that I get a clearer and crisp picture, and the bleeding is much less prominent. Also, FileBrowser 64, which was unbearable before, looks now a lot better. But doing graphics, for example booting into GEOS, it's still not on the level I wish it to be. Guess I really need to look into the VIC-II after all.
It's not like I've been telling you for hours already.
Lifting it out the socket turned out to be just a tiny little bit problematic, as I couldn't get by with the pulling tool. So please look away, as I lifted it slowly but gently using
a screwdriver. How dare you? It'll break.
Ah, who cares? It's obviously kaput already anyway. And here's the replacement VIC-II, which I'll give a brief surface cleaning, so I can also apply a heatsink. Now, let's see how things are. Alright, Dr. 64 is a lot better now, though there's still some bleeding at the end of those bars. But after all, GEOS looks a lot better now. And here we are in SimCity. Looks good to me.
You could have replaced the VIC-II from the beginning on already.
This C64 really cost me. Firstly, I'm absolutely not a repair expert for C64s. This is my first repair ever on any such machine. Secondly, I was working on this topic over and over again since June 2023. It was only like 5 evenings, so that's maybe not too bad for not knowing anything about this thing. Even though I invested countless hours besides that for investigating and reading documentation, and I barely even scratched the surface of the C64 hardware. Apparently the VIC-II was the issue, but not the only one. But besides everything else I've done, bringing in one modification as suggested by the retro channel to deliver proper Chroma output is certainly a big improvement as well for the video output quality. Plus, I more or less solved the riddle about those other modifications found on this machine, though I'll certainly continue my investigation. Next is to check out these floppy drives, because after all, I want to see this C64 running CP/M. What do you think about it? Let me know in the comments below. I'm the Vintage Collector, and this was my story for today. Thanks for watching, and see you again next Sunday.